Hi, welcome to everyone's favourite segment, Mailbag, now in 4K resolution, that is. Why? It's a thing, apparently. Shot on my new Sony HRX NX80 camera using my Rode shotgun mic. So let's get straight into it. Thank you very much, Neville Nobody, from Clavelli here in Sydney. I did already sort of sliced this open. I didn't know it was a mailbag, but so I didn't really look at it. So I know what it is though, and that distinct early 60s smell. Woohoo! Oh, for all you Avo fanboys, they all go wild. Check it out. It's the Avo Model 7 from that a date from the early 60s. Wow, the universal Avo Meter. A lot of people still swear by these things. They're probably still used in a few unis somewhere. A thing of beauty is a joy forever. Also, some people think of the universal Avo Meter. This is the classic Model 7 Mark II. Thank you very much. None of this Model 8 rubbish. And a lot of people think this is the duck's guts of analog multimeters. And even though, as much as I love analog meters, I'm not a particular Avo fanboy, actually. Yeah, I was never born and bred on them. I always thought they were a little bit ugly compared to the triplets and the Simpsons and etc. with their single range switch. I was never a fan of like the dual range switch. I was never a fan of how the mirrored cutout looked like this. I want to see the whole thing, you know, a bit of a square window meter fanboy. And anyway, a lot of people swear by this. And these are, you know, still it's kind of sought after to this day. People still want these babies. And look, it is absolutely enormous. It's just huge. But hey, Avo were the standard for a long time. I think they started in 1923 or something like that. And these were like the industry standard meter. It was one of the most accurate. It was one of the ones that had the most functionality. I mean, look, this one even has capacity, i.e. capacitance. They were pretty robust. They had electromechanical cutout protection here, and you know, just a lot of functionality built into this. And you could tweak the things, you know, Q was for like the gain of the thing on the capacitance and the high resistance, and P you can adjust some of the stuff in the resistance range to compensate for the age in battery in the thing and stuff like that. So you really had to know how to use these. They're a bit dickier compared to some of your more traditional analog meters. Let's tear it apart. Oh, look at all the usage instructions. Fantastic. And of course, it's made in the old dart, and it needs some of those weird-ass batteries that were likely discontinued before you were born. What's that extra screw in there? Alright, that seemed to be the ticket. Now I think she's going to come out, so this is a first. Let's have a look. Oh, clean as a whistle. Look at that. Beautiful. Don't you love the transformer? Thing of beauty. Oh, I'm glad I can bring you this in glorious 4K. Not that you really need it to see the details, but check out the one, no, it's not megafarad, it's 1 microfarad MFD. That's how they labelled them back in the day. 400 volts working, thank you very much. Is that probably like a big film cap? Look, they had to bolt that sucker down. That's just beautiful. And there's the meter movement. It's actually exposed if you take a look at that in there. You can actually see it. Come on. So I'm actually not a particular fan of being able to actually see the meter movement flapping around in the breeze in there. And here's our first knob. That was the P knob on there like that. And you can see, no, P doesn't stand for potentiometer, but you can see that it's just some nichrome resistance wire down there and a big contact swinging around. And then what? That almost looks like solder wick. Look at that. Just bent around there and then eventually connected down the bottom. Huh. There's the meter movement in there for you aficionados. I'll just swing that around. Beautiful. And you can see the other knob down here. This is the Q one that I showed you, and it doesn't engage. In fact, it doesn't spin unless you pull it down like that, and then it will engage and lock in place like that. That's like solder braid. It looks for all the world like solder wick, doesn't it? That's terrific. Anyway, more nichrome resistance wire there. I assume it's like nichrome. That's, you know, par for the course. But yeah, it's all very mechanical, isn't it? Oh. Uh-oh, Houston, we have a problem. Look at that. Wire's come loose. I assume this is a tag strip. But yeah, it's just, don't know where it's come from. It's one of those. I just find it fascinating how they do solder the wire under there, but then they kind of wrap it around and tie like a little knot in there. What are they doing that for? Some sort of strain relief or something? I don't know. It's kind of weird. And here we can see these have to be our shunt resistors. Take a look at these. The big copper band going over there like that. They solder on, hold their tongue at the right angle, solder at exactly the right point to give you your current shunt resistor. So that'd be your highest one. What is it, 10 amps or whatever the highest range is. Then that'd be the next lowest range. And then you can see the gauge of the wire getting thinner and thinner as we go along. And then, oh, in 4K, can anyone count the strands? In 4K, come on, you can do it. Some nerd's going to do that. Do my best to show you the range switch down there. There you go, and after all these years, all these decades, still hasn't corroded. Still probably works the day it came out of the factory. And you can see that it is dual wipe down in there. Yeah, you can see the extra wipe contact on the bottom, hopefully. Neat. Oh, check out the big ass reference resistors in there. Welwyn, thank you very much for playing. Panclimatic model resistors. Fantastic. 148k. Thank you very much. What would they be? Like 0.5% or something, probably. Anyway, you can see it's like classic old like tag board. Well, it's not really. It's not really tag board. It's like panel board construction. I'm sure there's a name for it. You know, they have the like turret based connections coming out here. The turrets actually make some connections on the bottom. You might, you know, we've got some. That's probably the most modern looking component in here. Is that no doubt carbon resistor there? Got 100 puff. Plus minus 15%. Thanks for playing. Lemco. Anyone remember Lemco? But yeah, basically sort of a it's not really tag board. It's like sort of turret board or something. I'm sure somebody's pointed out the real name for that before. So if you're wondering what the transformer's for, well, that's doing all the AC tapping. You'll notice that there's got to be multiple taps on here. Yep. All down in there to get the different taps off the different ranges for the AC. That's how they do it with that transformer. Neat. And for those interested in such things, there's our electromechanical cutout down in here. And this is all, you know, it'd be like bimetallic strips and whatnot to actually engage and then latch off if it got an overload. So there you go. That's the Model 7 Mark II Universal Avo Meter, which was probably the industry standard multimeter back in the day. It's before my time, and I just never had the same affinity for them. Yeah, but I'm sure a lot of people do, and I can understand why. You know, they were a beautiful meter for the day, and it had the performance to match for an analog meter anyway. But yeah, it's just all hand-built in the old dart. Ah, love it. And yes, it does smell like 1961. But sorry, this bad boy is actually busted. Feed voltage into it. It doesn't move diddly squat. So yeah, we're going to have to leave that for another. Maybe that could be a vintage repair video. Oh, look. Let's put insulation on the sides. Why? They've glued them in and glue's come off after all these decades. But check this out. Look, it's like we got the spring battery contacts. There's no wiring from the front panel. And they just actually connect to these 3 spike terminals down here. Look at that. It's pretty clever. Now we're talking. Check it out. Giant flippy dot display. We've had flippy dots on the EEVblog before, but they were tiny compared to this beast. Look at it. Thank you very much, Gab Young 92 on the EEVblog forum, who basically was going to toss these out, and I said, yeah, I'll have them. have a play around with it. Anyway, it turned up in quite a large number of big boxes, not actually a mailbag item. So I was going to do a separate video on this, and I did actually shoot some footage and posted a couple of photos on Twitter, I think, and we'll take a quick look at them, but I wanted to like hook it up to like an Arduino and actually get them working, so I've got to actually hack the controller that comes with it, which is totally crusty. Stick around in a minute and I'll show you. Oh man, it's probably the worst soldering you've ever seen. You'll see it in 4K. Fantastic. These are like these outdoor displays. These ones are, well, I think they're made in they're made in Bayshore, New York, by Staver Co. Inc. There we go. And they're from an Australian company who does like horse racing events, signage, like outdoor signage for horse racing. So these were used like the tote board or the race time board or something like that, and they come in different versions. That's obviously a 7-segment display one, and they come in like little single rows like that, and you just combine them all to give like time and, you know, race times and odds and things like that. I don't know, whatever it is for the horse races. But very cool flippy dots. I love them. They're just gigantic things, and unfortunately, you can see all this black like mask. It's not solder mask. It's like some other like matte black coating, so that outdoors they just appear like a black background. They want the contrast between the yellow and the black, and that's all just peeled off, and horrible stuff. Anyway, let's have a quick look at the controller that it came with, because it's shocking. These aren't flippy dots. These are flippy dots. Oh, look at that. We've seen these ones before, and these were very cute and tiny. I love them. These are gigantic outdoor ones. They're absolutely enormous. What are they? Let's have a squiz. Almost 40 millimeters, 38 millimeters diameter there. Absolutely enormous, and they work exactly the same, but these are going to be higher voltage, higher current, you know, higher mass in terms of flipping them over, stuff like that. So we're talking some serious grunt to drive a big matrix of these, especially, you know, a big connected matrix. And you can see how all that black, it's not solder mask, it's, you know, some sort of you know, matte black coating is just worn off, and it just flakes off. If I touch that, it just gets all over my fingers. It's horrible stuff. Speaking of horrible, yeah, look on the back. Oh, crusty. But if you think that's pretty piss poor, wait until you see the controller. Anyway, there you go. Staver Co. Inc. Signal X. This crap I got on my fingers. And here's the controller for this thing. It's pretty how you doing. Look at this. We've got ourselves a toroidal mains transformer here. Yes, it's just got some bullet connectors there connected to some mains cable. And well, at least they've, you know, at least they've added some heat shrink and cable tied it down. But Supertech Electronics, is that just Racing Queensland? There you go. That explains it. Queensland. Say no more. Sorry, that's just a little Australian in-joke. Anyway, what is probably like a reasonable solution for this, because you're going to want, you know, your row column driver cards. Got a power supply card here, row column driver cards, and then a processor card, which is just stuck on how you doing style on the outside. They obviously didn't design this. This is obviously an off-the-shelf controller card. There you go for you 6809 fanboys. We've just got some I/O interface, serial interface, some RAM and ROM, and, you know, a few miscellaneous chips, and obviously designed to an existing design board, off the shelf one that they chose, designed to plug into an existing rack, and they just basically just didn't bother. They're just interfacing via the I/O over here, and that's pretty much it. It's all you need it for. It's fine. But you've got to see this back plane. Look at this. And I'll get the macro lens out. I'll show you these solder joints up close, because they are horrific. The humanity. That is not as dry as a dead dingo's donga. That is drier than a dead dingo's donga. Unbelievable. Look at that. Wow. What the hell were they using? Like a plumber's soldering iron or something? This is just awful. That has to win some sort of award. Anyway, like the Bad Flux of the Day award. Unbelievable. I suspect, though, like someone might have had a go at these two, because these ones over here are a bit better, but, you know, not exactly stellar, but compared to the other two, it almost looks like they've been reworked. Unfortunately, it doesn't get any better for the row and column driver boards. Look at this. Unbelievable. Like, just, like, that is shocking. That is just terrible, Muriel. Oh, have you ever seen something so bad? How did these things ever work? I mean, the original production soldering, by the looks of it, was, you know, not great. Although it's probably okay if you, maybe if they cleaned all the flux off, might be able to do the business. But whoever's repaired these, what were they using? Like a 500-degree plumber's iron or something? Unbelievable. Anyway, it's just got the expected ULN 2003 Darlington driver transistors. They're driving. Looks like they're just driving some larger MOSFETs up here. And then it looks like we've just got the single rail here. And, of course, the large current trace supplying all that. And there's your other power rail in there for the basically logic level into MOSFET driver. And then it doesn't get any better with the column driver board over here. Although it does look a bit, the soldering does look a bit neater. And we've got some digital action happening here. Oh, some 4000 series CMOS. Thank you very much. Once again, driving some MOSFETs up here. We've got the back EMF diodes as well. We had those on the other board, and it's a bit better there. And House of Brook, that's the company who obviously designed these. That is like an Australian company who's into all these gaming, outdoor venue gaming type display systems. Anyway, so no doubt the House of Brook designed these row column driver boards, or they had someone actually design them, probably wrote the system software, designed the rack and built the rack and all that sort of stuff, and then the US company actually supplied the flippy dots, and then so this company was probably responsible for integrating the entire system. And well, that's basically what they do. They provide these outdoor venue display things. I think they're still going. They might have been bought out by a company or something. I don't think they run under that name anymore, but so I hope who's ever in charge of all this is not in the business anymore, because it's just terrible. Like, this system design is probably, it's okay. It's what you'd expect. These are low volume stuff. It's not massive volume. So, and the layout of the boards and everything's fine, and the backplane is, everything's okay, and sort of tacking the processor board on the side is fine, although I would have, integrated that into the rack. But, it's okay for sort of like these low volume sort of, one-off contract jobs or something like that. That's quite common in the industry. But, yeah, the manufacturing of it just totally let it down, and then the repair let it down even further. Unbelievable. Then the system was just all connected with these large pin pitch ribbon cables like this, and they just daisy chain between modules and plug into the row column driver boards. They probably had more than one rack, of course, depending on the size of the display system. Probably, join those together somehow in maybe a larger computer-controlled system unit or something. This processor board might have just been responsible for, like, converting, serial ASCII data into the 5x7 display matrix or something like that. So they just plug all those onto the back of here and cross your fingers. There you go. Hope you work, complete with bodge wire and dodgy soldering and horrible flux residue and everything else. And yeah, that's what you got at the races. If you go to the trots, that's what you were looking at. So I was hoping to hook this system up to like an Arduino or something, and then just, sort of write some software just to display some stuff on it, these large flippy jots, but they're in such horrible condition, and, I'd either have to design and build my own driver boards, or try and, hack into the existing driver boards in here, which shouldn't be too hard, but oh, geez, it's just, the whole thing's just so crusty, it's not worth it, I don't think. Thank you very much, Oswald Brzezinski, in Orbis, in Deutschland. Hi to all my Deutschland viewers. Let's have a look at what Oswald has sent in. Tongue in 4K How's the mic? I don't know. I'm just using the Rode shotgun. Sorry if I've like goofed up any of the settings. I'm still learning the camera and stuff like that. We have a note. Whoa, video enhancer and audio mixer. 2-minute teardown. And oh no, we've got ourselves a crusty burger soldering iron. Let's have a look at it. So thank you very much, Oswald, from the YouTube channel Brotshoe, which means bread shoe. Of course, why not? For a tutorial and reviews and random stuff channel. There it is for those playing along at home. Check it out. It's in German. A hammer, video enhancer plus audio mixer. Bildenschwaf in my fluent German. Ton Mischer. I don't know. I got no idea. Jeez, let's take it apart. Gotta love the old 2-screw Pactec cases like this. Pactec's a brand name. They went under various different names back in the day, but in Australia they were called, they sold the Pactec ones at J-Car and Tricky Dicks and other places, Altronics, and that's kind of like a generic name for them. So let's whack it open. We're in like Flynn. Geez, there's not much. Single-sided layout, look at that. Pretty Spartan. Geez, they've left some decent leads on those trannies there, haven't they? Wow, there's nothing like long legs on your tranny. It's great. You can get your probes in there, your easy hooks, and hook your probes and hook them straight on. Fantastic for debugging. Love it. I assume that these are just large caps. I don't know the RDE brand. Is that a German thing? I just assume that they are large electrolytic caps. I just haven't seen like the red case, like almost like a solid case. Usually they have like, you know, the plastic on the outside and whatnot, and even the other electrolytics here are you know, I know they're the Philips ones, but I haven't seen those in a long time. They're the metal cans with the clear plastic little condom on them. Anyway, nice looking mains, PCB mount mains tranny there. You can still get those. They're a beauty. 7812. But there's just nothing else going on there. What, it's a discrete transistor audio, like amplifier. It does some filtering, probably, right? That's what these caps are in here for. Doing some, you know, filtering, AC, like some bypass. Oh, I love the extension knobs there. That's pretty schmick. Yeah. Oh, look. The rods pop out the back. Neat. And for $10 at the local food store, like, do I even want to? I don't know. I've never heard of a Parkside. Is that a German thing? I don't want to. It's mains in, is it? So it's actually mains in. What are these three things on here? Does it do something else? What is it? Wow. Look at this. It's got the dispenser. I was going to say, is that like, does it spool out the solder for you? Oh, right. I thought these were buttons or something. They're not. What the? And where's my sponge? So we've got our sponge there. We've got a big chisel tip, which looks like the biggest load of garbage I've ever seen. Look at that. That's not even plated. Like, what? Is that just like chrome or something? Like, and look at these pissant little spools of solder. What use is this? Unbelievable. Welcome to the 4K sponge porn channel. Whoa. Who the hell designed this, and how is this a thing? This looks like a space modulator. Oh, okay, so that was a spare tip. So you get a Dodgy Brothers. Oh, man, that is ridiculous. Look at that. Like, that. So it looks like we got, like, minimum. What's it? Like, you've got to turn it all the way around here to 100? Geez, that's a long way to 100, isn't it? It's a long way to the top if you want to rock and roll. And up to, like, it does maybe up to 480, if it's bloody well regulated at all. Unbelievable. I'm sure it heats up, but I just don't care about its performance. There's no way I want to use this thing. Well, look at this. Attention to detail. They put a big metal plate in the bottom of that. Give it a bit of heft. Good on you. Here's our mains cable coming in. Well, okay, it's got a cable grommet. It's going in here. They've at least put some heat shrink on there. Well, it's actually quite reasonably made and constructed. If what you want is a bloody non-temperature controlled, triac controlled PN 0506 for those playing along at home, just a triac controlled, which means that they just chop up the AC waveform and drive the element, which is, oh, where is it? Yeah, it's going up to here. There you go, they're driving the elephant. At least they're running the mains into there like that, so, you know, the tip would be mains earthed. But it's just chopping up the AC waveform. There's no temperature sensor in the tip at all, and it's just how you're doing. You know, set the temperature, cross your fingers, hope your mains doesn't vary, and, you know, hope it's kind of, sort of within plus minus 50 degrees. I don't care how cheap these things are, just do not get a non-temperature controlled soldering iron. Just don't. I'm not even going to power that up. Even though it's actually, you know, like apart from the quality of the, you know, lack of quality in the metals and the tip is just a joke. You know, it does, like the case and the handle and everything. It feels all right. That almost feels like a, you know, a silicon type outer rubber. It's not, but it's very nice rubbery feel. Like everything's done okay, but it's just a non-temperature controlled, you know, SCR triac based controller. But I guess if that's what you want, okay, passes. They have the hide to call this thing a soldering station. Bullshit. Soldering station's temperature controlled. What a load of rubbish. Thank you very much, Brumby, from the EEVblog forum for sending this one in. He actually sent in like an iPhone that I could, because I don't use those newfangled iPhone things, for the EEVblog 121GW meter app development. And yes, it's working. It's now in beta and people are using the app. Anyway, thank you very much for that. But also sent something else in here, which I haven't really looked at yet. So let's have a look. Ta-da. Yeah. When this baby hits 88 miles per hour, you're going to see some serious shit. This is great. Look at this. Oh, I'm not sure what vintage that puppy is, but anyway, it's a Handycam Video 8 PAL, none of that NTSC, never twice the same color rubbish. And stark contrast to the NX80 that I'm using at the moment. Wow. Video 8. Awesome. So that obviously can't be a 2-minute teardown. That's got to be a separate teardown. We love vintage. I've done, was it a Sony camera? I'll try and link it in at the end. I did some sort of old vintage camera. This was probably more up to date than the one I did before, but that could be interesting. Thanks, Brumby. Thank you very much, Elektor, for having another suck of the Sav. They've been on the mailbag many times. So, let's have a squiz. Ooh, we've got Elektor Magazine, ESP32 Design Contest, etc., etc. Sorry, I don't read Elektor anymore. I never really did, because it wasn't, it often wasn't available here, so growing up, I just didn't, I just didn't get it. I just had the local magazines. Yes, it's Elektor hailing all the way from Europe, with a little something for your mailbag, which we love, by the way. We just tried to contact you on your hate email address, but it got rejected. Yes, I do actually have a hate mail address. What is it? Hate at EEVblog? I can't remember. It's on the website. And people do send comments through to my hate mail, and I do actually read them. Because it's just part of the fun of doing the job, you know. Anyway, what do we got here? This is not a book. This is not a book. Very excited. It's a Nixie tube kit. Look at that. It's a clock kit. Cool. That might be a good one to build with Sagan, perhaps. Anyway, I'll link it in down below. We'll take a quick look at it, but obviously I'm not going to assemble it for this mailbag. Thanks, Elektor. Okay, let's have a quick squiz at this tube clock kit. Check it out. Spared no expense. Elephant 14. Yeah, call them Elephant 14 from now on. Power mic, that sounds good. Don't know why I didn't think of that years ago. Power module. Geez, that's gilding the lily, isn't it? There you go. Oh, we got some of the old school drivers. I think we do. ESP32, very nice. I just love real resistors like that. Oh, fantastic. Or your basic semiconductors. Got another, is that a little power brick in there? Not sure. And what else we got? We got our tubes. Let's have a squiz. Phillips. Oh, wow. None of this Russian rubbish. Oh, look. Are they like, they must be like a decimal point. Are they? They're using those as a, for the clock display? I can't fold the damn thing out. Anyway, there's our, at least they haven't gone LEDs. Like, they've gone completely vacuum. So, here's the Rusky tubes. No doubt, the Ruskies were the masters. Alright. Oh, look at that. Beautiful. The NB22s. 92? Pretty recent. Cold War was over by then, wasn't it? Oh, hang on, I'm going to show that in 4K. Welcome to the 4K Nixie Tube porn channel. Whoa. Beautiful. Look at that. Thing of beauty. Joy forever. Oh, at least they're gone for the matte black, haven't they? Don't mind the matte black. None of that glossy rubbish. And they've obviously got a multiplex design because you can see them all connected in parallel like that. Unlike my video, which I might have to link in, where I've done auto routing of a board with more digits than this on the Nixie Tube subscription counter video. And yeah, just not enough pins to drive it. So obviously they're multiplexing this little baby. Anyway, that looks like a neat kit. Maybe I'll assemble that with Sagan sometime, perhaps. That could be a decent introduction. Nice through-hole board. Great. I'll link it in down below if you're looking for a Nixie Tube clock. I tell you what, I haven't looked at Elektor in a while, but I'm pretty impressed with the content and the, the presentation, the layout, and everything else with it. This is really quite impressive these days. I like it. There's a familiar name, Robert Lacoste. He's been around forever. And there's like great articles on, in this case, wireless protocols and stuff like that. This looks like Zigbee and, LoRaWAN and wearable LED controllers. This is by a staffer at Elektor Labs, by the looks of it. But there are, this is the Elektor editorial team, but of course you can still get contributed articles. Tam Hanna from Germany, I presume this is a contributed article, and still and Oliver Crosset from France, still a fantastic way to get something published and showcase your projects and put in your resume. This is great. There's an article on EMC limit values, CE declaration on products and stuff like that. It's only short, but geez, not bad. I'm thoroughly impressed by this. Well done. Thank you very much, person unknown. Just from Eastern Creek here. So let's have a squiz. Eastern Creek is just up the road, kind of thing. There's a Eastern Creek Raceway. Been there a few times. Ridden go-karts around Eastern Creek Raceway. About 18 months ago, I cleared out the premises of a company called Pandora. Should I name them? A company which used to manufacture high-end color grading equipment. In the film and television industry, the Pandora Pixi system allows studios to color correct video footage in real time up to 2K resolution in the late 90s and early 2000s. These are the scrap PCBs. Wow, oh, look at those Xilinx bad boys. Wow, let's take a look at this. Oh, it's got that crusty old PCB smell, all right. Well, not that old. These are like, we've got vertexes and wow, there's a whole bunch on here. So we've got PCB porn. Thank you very much, Carl. And he has no exact price, and he's been told that a complete Pandora Pixi system would have cost around $1 million in the late 90s. Wow. Unbelievable. Now it's worthless. There's the details. Thank you very much, Carl. Let's take a look at these boards that they're from systems that cost around £1 million or something like that in the late 90s. Did a 2K resolution. Incredible for the day. They designed everything in-house, apparently, including all the software and everything else. Look at these badass Xilinxes in there. Wow, they would have cost a fortune in the day. XC 4085, I don't know, you could go look up the, oh, no, XCV 1000, I don't know, were they top of the line for the day? But anyway, that's a channel SCC board for whatever that is. Like little, they're IDT RAMs, are they? Possibly. Buffer memory, some smaller Xilinx processors. Once again, this is very common. Just to do the power, you wouldn't bother rolling your own. You just get like an off-the-shelf, switch mode module that just does the business and whacks some caps on there, because you want to spend all your engineering doing the engineering time doing the rest of this. Wow. There you go, just a couple of bypasses on the bottom. 99 vintage. Pandora Pluto, there you go. So obviously we've got, are they, I presume, are they like RGB colour in or something like that perhaps? I don't know. What do we got there? It's an Altera job. So they've mixed Altera and Xilinx. So obviously maybe they had different teams doing this, and they, one team favoured Altera over Xilinx, or they actually chose them because of the specific requirements on there. Once again, these little off-the-shelf power supply modules, very common, and you can salvage these out. These are very useful to salvage from these boards. These, of course, wouldn't have been manufactured in high volume. They would have sold, hundreds of systems, if they were lucky, maybe thousands of systems, something like that. But they cost, so much money that to actually develop these things, it's just phenomenal. That, price was no object in terms of the hardware. A Genom GS2971A. I don't know. Look that one up. They were serious about the power on here, weren't they? Look at that, 5 volt in and then getting 0.9, 1.8 and 3.3 volt rails. But that's a serious bit of juice. Don't know what this is, but look, Raytheon parts? Interesting. Are they like, is it a Raytheon chipset, or is it a Raytheon like gate array, or I don't know. I thought they would have stuck with the Xilinxes that they got on there if they needed a gate array or anything like that. Once again, it looks like they got some IDT, that'd be SRAM probably. Yeah, almost certainly. And interface stuff. Good old zero power RAM, the lithium battery backup built into there. Ooh, I love those little dot matrix LED displays. They're fantastic. Yeah, this looks like some sort of PEC. Well, it's a PEC control card. So it doesn't actually say prototype, but it just, looks a bit more sort of do-it-yourself than the other ones were more what I expect out of a production type product. Vertex 2 Pro, that would have cost a pretty penny back in the day. So that's obviously some sort of door-to-board. We've got high-speed board-to-board interconnects there. But yeah, that's pretty much all it is a big-ass FPGA surrounded by some memory. I've got another Spartan down there. But yeah, that's all it is. Just custom processing. Oh, check this out. Isn't that beautiful? Classic pin grid array expander. Basically, they're custom designed to go onto the existing pin grid array sockets on the board. So you plug it in and then replace them with, in this case, surface mount. What are they? Some sort of memory? Something like that. So obviously, to convert an older design, upgrade, they probably couldn't get these chips anymore, but it was too much effort to redesign the main board, so they just designed this. It was, yeah, I've done that before, guilty as charged. But it works, it's brilliant. Bingo, we found the main board that this plugs into. Once again, look at this, B and C's, they don't label them RGB or anything like that. Are they like SDI inputs for video? I'm not entirely sure, but there we go, another big Vertex 2 Pro on there, and the module 2, there you go, designed to have a separate one on there, and international rectifier modules. And I do like that closely spaced array of tantalum caps. Oh yeah, beautiful. Just love rubbing my fingers over that. Beautiful. 74.1758 megahertz crystal. They probably had to get that one custom. But it just goes to show
what badass technology you can get at these, you know, practically unknown companies in the industry that have these niches, but they need to develop these absolutely bleeding edge at the time hardware. Fantastic. The design team for something like this would have been huge. Would have been great to work on. This is just getting crazy. Carl set in so many boards. I can't possibly show you them all and go over them all in any detail, but it's just nuts. Look at it. Wow. Look at all the IDT memory on the back. This is interesting. Look, couldn't get enough power through the connectors, or they just didn't bother. That, what do they got? +5 and plus 3.3 volts there. Coming in separately to power this bad boy. Wow. What is that? That's a Motorola job. XC563. What's it like? Is that some sort of gate array, or is that a some sort of Motorola processor or something, or some custom job? Because considering that they're using all the Xilinx FPGAs, you know, you wouldn't bother, you know, engaging someone to do a custom ASIC unless you absolutely have to. You know, like power didn't seem to be a problem. You know, high volume manufacture, getting the price down wouldn't be an issue with something like this. So yeah, I'd be very surprised to find a custom ASIC on something like this when you can just run it all inside FPGAs, unless they weren't as capable as they needed at the time anyway. And apparently all this badassery is just for, like, color correction. Like, I just find it absolutely remarkable that it requires this much hardware for color correction. Granted, it's up to 2K, which was phenomenal back then, but wow. Anyway, thank you very much, Carl. This is just, wow. I'm definitely going to keep these boards. These just, you know, beautiful. You can frame these and put them on the wall. Gorgeous. Oh, stop it. Just stop it. The grunt on that's incredible. More BNC inputs or outputs? Don't know. You'd have to look at the individual chips. You go to town on this all day. Oh, here's our prototyping board. Check out this. Yeah, Pandora color processing engine. Oh, that's somebody's original hack. Fantastic. Our first 4K postcards. Check it out. Sweet. Thank you very much, Nordic Semiconductor, who is, I'm sure, is having another suck of the sav. Sorry, did that, like, clip the audio? Like, when I rip things open, I see it on, like, the audio waveform. I can see it, like, clipping and peaking. Occasionally I try and, anyway, NRF ready. We've got a smart remote. What's a smart remote? I guess we'll find out. It's a good thing about my postcards. 4K postcards. Beautiful. Fantastic. Look at that. Bobby Dazzler. Alright, I hope they're zooming in correctly. The applications team at Nordic Semiconductor would like to send you some of our latest development kits. The Nordic Thingy. Internet of Things sensor kit. 4K eye roll. What on earth is that? It's not chocolate. It's light. So they're like biscuity things. There's chocolate. Feel the chocolate density in that. Beautiful. All right. It's the Jap. The Jap. Lucky it's got 2 P's on there. Anyway, that's like that looks kind of like a Mars bar kind of thing equivalent. Anyway, we've eventually got the Nordic Thingies. Geez, they're pretty weighty for what's in them. Thank you very much for the nibblies. So we've got a development kit, and oh right, because it's a module and it's got a rechargeable battery and all sorts of whiz-bang stuff in it. Thank you very much, applications team at Nordic Semiconductor. Let's take a look at the Nordic Thingy real quick. I've downloaded the app and that was pretty seamless. And here's the little module. Let's check it out. I actually rather like it. I just pried it out of this little rubber baby buggy bumper here, which has just got the USB interface there.
And apparently, like, you take it out and it's got, we can turn it on. Here we go. They say, oh, yeah, there it is. Oh, it's lit up blue. So it's on now. I like the antenna, how they've got that on the flat flex like that, just sitting over the back. That's really quite nice. We've got ourselves a big fat lithium ion cell in there, or lithium polymer. And I don't know what type of sensors are inside this thing, what it can do. I guess we'll find out. But anyway, I do like the design of it. Looks jazzy. Yeah, flishy flashy. Alright, I'll put it back. See if we can see what we get on the phone. Not sure why you need location to grant access to the Bluetooth low energy devices, but the 121GW software did a similar thing. It was just the Xamarin development environment or whatever it was just made us do that. So, yep, connect to a thingy. Let's connect to a thingy. Let's scan location services. Yeah, okay. NFC. Let's scan. Location services disabled. So we have to enable location services on. Don't know what. Yeah, that seems a bit rude. Anyway, scan. Hey, we got it. We got one. There you go. Oh, green. It just flashed green. There we go. We're connected. That was seamless. Well done. Thingy name. Get started. Tap to navigate to other services. Yeah. Okay. Temperature. Yeah. Tap here to start stop sensors. Okay. No wuckers. There we go. We've got barometric pressure. We've got temperature. That seems about right. And humidity. Oh, CO2. Wow. There you go. And what's that in parts per billion? I don't know. And what's that? FFFF. Is that like a colour thing? Not entirely sure. But there you go. You're automatically... Can you scale? Can we scale that? Yeah. That's a scaling... That scaling seems to work really... Oh. Can I double tap to get it back to centre? Nah. There you go. Oh. No. No. Could do with some polish on the pinch and zoom. Works okay in some respects, not in others. I want to scale that. I want to auto scale. Can I just click on that on the side? Nah. What's going on here? 40% humidity, pressure and temperature. There you go. It's just an environmental sensor, but that worked quite nicely. Wonder what the battery life is. So I rather like the design of the case. I presume that that's like for some sort of lanyard. You could, like, you know, put some sort of lanyard cord through it and attach it, you know, hang it off your backpack or something like that. I don't know. Does it do any internal data logging, or do you have to get it, like, continuously connect to your Bluetooth app? It would be a bit disappointing if it couldn't log internally. That'd be nice, and then extract it via USB. Anyway, I don't want to do a full review of this thing. I'll link it in down below if you want to check it out. And they have a development board which looks quite comprehensive as well. You can reprogram the firmware in this apparently, so I'll link that one in as well. But yeah, it'd take ages to go through and do a proper review of this thing. But if you're wondering why they've got these little pads on top of even the pin headers over there, they're SMD placement, so that the pick and place machine, because these are actually surface mount, you'll notice that they're not through hole. Surface mount connectors, so the pick and place machine comes along, boop, boop, places them down like any other component, and then they're reflow soldered. Oh, I can make it toggle. Oh, you probably heard it. There we go. Yeah, and you can push that button through the rubber as well. Neat. Let's open a random crap Chinese eBay widget that no doubt costs like $1 including postage. Let's check it out. I do still have some old footage of, I was going to do a separate video of just tearing down a bunch of cheap eBay stuff. I've still got the footage somewhere. Maybe I'll still release it. What the hell? I guess they're couch feet. That's all I need. There's more couch feet. Crazy potatoey mailbag. I know what's in here. If you haven't heard of Potato Semiconductor Corp, yes, that is their name, Potato Semiconductor, then you're in for a treat, because Potato Semiconductor have cornered the market, and I'm sure it's an absolutely large market, of gigahertz range, gigahertz speed, 7.4 series logic, apparently. And they've no doubt sent in a few chips. Thank you very much. We've got a, a 7404 and a, I can't read the other one, 14 and a 3014. I'm not sure. I thought they only made, last time I looked, they only made 7400 series logic, but they've got their own patented, presumably patented process technology that allows them to go up to like a gig or more or something like that, for a real niche application. So obviously that's going to take a bit of, I really want to experiment with these to see if you can actually get these to operate at the claimed 1 gig, 7400 series logic. I think we might have a hard time probing this. Might have to borrow a better scope. Richard KO, thank you very much, Richard KO from Potato Semiconductor Corp. And as far as I'm aware, last time I checked, Potato Semiconductor was like literally, I believe, run out of the guy's garage. So, awesome. Thank you very much, Mark Vich, V-I-C-H, from Rhine in Deutschland. Deutschland again. They're crazy about mailbag in Deutschland. Anyway, let's have a look at this. I kind of know, I know what type of thing is in here, but why? Thanks for your help. As promised, a small gift, one of my projects from 2016. Hope you enjoy. Thank you very much, Mark. And Rockabilly Renaissance. Just what I wanted.
Hey, there's a on the street where everybody goes, do a lot of boogie, rock and roll starts popping the blues. Till daylight, come on, baby, let's rock tonight. We're gonna rock and roll.
Person unknown again. Thank you very much. We've just got a random electronic tool. Could be anything. Could be a farty novelty gadget. Could be a spanker meter. You don't know. It's the luck of the mailbag. That's why I love it. Comes in a box. I was inspired by EEVblog number 102. Do-it-yourself constant dummy load. Do we have another dummy load? Man, it's ridiculous. I should have sold dummy loads kits. Like, I would have be a billionaire by now. So this is Jaspers electronic load, and it uses the STM32 ARM Cortex A3 processor, which Jasper says he gets for $1.72 on AliExpress. He couldn't make it cheaper himself, and it's a great MCU. No kidding. It's just, like, to get that for $1.72. Are you kidding me? What kind of world are we living in? Unbelievable. So there you have it. It's a computer-controlled dummy load. I won't, power it up and play around with it. But if you want to check it out, then by all means, 12-bit ADC built into the STM32, even though they're not the best ADCs in the world, it's going to be fantastic for a dummy load like this. Terrific. Designed for, DC supplies, solar panels, battery capacity. Yeah, total power. Heatsink can dissipate about 18 watts by natural convection. The software, the power is also limited to 18 watts. Yeah, that's smart. Definitely. So, there you go. The only issue I have with that is a bit of rockabye baby on there, because the bottom pins haven't been soldered in. The whole idea of these pins is that they're actually tin-plated pins that are supposed to be soldered to large pads on there. So that's what I do for the next revision of the board. But they, you don't have to do much. I presume that's just a little LM324 op-amp, just like my original design or something similar, and that's all you need. You need a MOSFET, you need an op-amp, and you need something to set and read the voltage from that. And that's all she wrote. Everyone should have one of these constant current, and in this case it can do, because it's computer controlled, it can do constant power and constant resistance, and as well as the constant current dummy low, because it's computer controlled, you can do that. Whereas the one I did, which didn't have any smarts, it was just the op amp, then that was only constant current. But with a bit of software smarts, you can do the others. Neat. I'll link it in down below. Check it out. It's on Tindy. Thank you very much, Perushka Sunyo from Budapest in Hungary. Hi to all my Hungarian viewers. I don't know, does it rank in the top 20 countries? Maybe. Let's have a look. I like the feel of this one. Don't know what it is. It's red, so it's got to go fast. So let's have a look. Come on. Oh, that's the bubble wrap inside the thing. Dear Mr. Jones, I really hope you will enjoy. Thank you very much. What is it? Yeah. Beautifully bow-tied. What will I enjoy? Will I enjoy it? Let's have a look. It's a... Oh, it's very well protected. What is it? Oh, wow. Yeah, was I clued up on this? Old Hungarian Electronics Magazine. Check it out. Anyone subscribe to that? Anyone remember? It's not particularly old. Is that 91? Or is that issue 91? Maybe that's issue 91, is it? Does it have a date? No, it's 1991, issue 1. There you go. Wow. I don't understand a word of it.